One symptom that seems to annoy a lot of our readers is pinking or detonation. When we're accelerating, it will manifest itself as a rattling noise from within the engine, typically the top part of the engine. It's often been described as someone rattling a tin with very small bearings inside it. But what's happening? What causes this pinking condition? Is it serious? Should we ignore it? Or is it something that could escalate into a much bigger problem? I need to point out that the terms knock, detonation and pinking are strictly not the same thing, but most people will use them virtually interchangeable. They are similar. They all relate to abnormal combustion events. Knock is a general term that can be applied to pinking and detonation. Detonation is a far more serious abnormal combustion event where there's a literal explosion of the fuel where everything burns far too quickly, and you notice that that doesn't typically produce the gentle pinking noise that we're talking about. But the causes and symptoms are very, very similar, and because people use these terms interchangeably, I'm going to use the terms interchangeably through this video and create a general video that covers all of the bases. Whatever your issue, whether it is knock, pinking or detonation, this should go a long way to help you diagnose the source of the problem and get to the bottom of it. We're going to help you diagnose the source of pinking. In fact, in about 80% of cases, it's nearly always down to poor quality fuel, carbon buildup inside the engine, lean running, overheating, ignition or timing issues, or a faulty knock control system. The other 20% are usually down to more serious tuning problems. You might be dealing with LSPI, low speed pre-ignition, particularly common on turbo engines, injector faults, general tuning errors in the map that has been applied to the engine, or physical defects inside the combustion chamber. To diagnose it though, we need to ask ourselves, when does this pinking or detonation occur? Has it happened immediately after we've filled up? If that's the case, it's probably the fuel that we've just filled up with. If it wasn't doing it before, the only thing that's changed is the fuel. It could just be a bad batch of fuel, or the fuel could have the incorrect octane. Octane helps the engine resist detonation and knock. If your engine likes the higher octane fuel and it's suddenly been dumped with a lower octane fuel, the threshold is going to be much tighter and you're going to start to experience pinking. Does this pinking noise only happen on heavy acceleration? This could be an issue with knock control, the fuel quality, or carbon buildup. Carbon buildup causes hot spots inside the engine, and these hot spots act potentially like a spark plug, pre-igniting the fuel in areas you don't want it ignited, causing a secondary flame front or an uneven burn of the fuel inside the cylinder. Does this only happen when the engine is hot? Has the engine started running hotter than usual? We could suspect then it's probably an issue with the cooling system, but it could also be a fault with lean mixture. Lean mixtures tend to run hotter and produce more heat, and are also subject to the risk of detonation. Does it happen at low RPM at high load? You're not going that fast engine speed wise, but your foot is down on the throttle. You're asking a lot from the engine. This could be LSPI, low speed pre-ignition. It could be down to carbon deposits inside the engine. And again, it could be attributed to incorrect fuel. Does it happen all the time at all loads? There's no specific pattern. Well, if pinking occurs wherever we are in the RPM range, whatever the load is, we're dealing with a problem with the ignition timing or a severe engine management fault. Perhaps a sensor has packed in. Has it started after we've had some work done on the car, particularly a service? If that's the case, it may just be that the wrong parts have been used. The wrong spark plugs. Spark plugs typically come with a temperature range, and the temperature range determines how likely they are to cause knock. But it could be a timing issue or even a sensor fault. When someone's been working inside an engine, myself included, it's very easy to knock a wire to cause a loose connection. Let's drill down into these faults and see where the problems lie and what we should actually be checking. Wrong fuel, we've already mentioned that. The octane in the fuel resists detonation. The higher the octane, the more resistant it is to detonating or pre-ignition. Try a top up from a fresh fuel station with high octane fuel and see if the problem goes away or the problem reduces. If it does, you've probably just got an issue with the fuel quality and the engine itself is okay, or maybe the engine's indicating that it's running toward the upper end of what it can work with and there's some other potential fault inside the engine that needs to be addressed. Carbon deposits tend to build up over time. The carbon is basically just soot and oil and other particles from the combustion process that have started to bake and solidify on the cylinder walls or around the intake valves. Now, these get hot, they create hot spots, causing the fuel-air mixture to ignite prematurely or to ignite unevenly. This will typically get worse over time. It's not a problem that suddenly happens. There's a progressive nature to that. If we pull out a spark plug, we can actually use a borescope to see what the condition of the cylinders and the intake is inside the engine. And if we see a lot of carbon, then we need to do a carbon clean. That might just mean we run some carbon cleaner through the fuel system and take the car on a very long drive to help get rid of those carbon deposits. That can, in some cases, be very effective. But in many cases, we need to think about doing a walnut blast on the intake, because the problem is generally on the intake as well as inside the cylinders of the engine. We need to ask the question, why is the carbon building up in the first place? Is the engine running too rich? Is there another problem perhaps with the positive crankcase ventilation system or other components inside the engine that are causing this carbon buildup? Just looking at the spark plug, if that is covered in carbon, you've almost certainly got a carbon problem inside the engine, and you need to really work out why the engine is producing more carbon than it should. You might also have noticed an increased oil consumption on the engine, and that would indicate the oil is seeping in, burning and causing these carbon deposits. Addressing that oil leak should really be a top priority for us. If the ignition timing is too far advanced, that can cause a detonation and pre-ignition. If the spark happens too early, cylinder pressure increases before the piston reaches the top dead center position. This causes a spike in pressure, also a corresponding spike in temperature, which are the ideal conditions for knock or pre-ignition to take place. Using a good quality scan tool will give us an insight into the ignition timing data and might help us to determine how advanced the ignition is and whether that could be causing the problem. But also check physical things in the engine like the crankshaft and the camshaft timing, the sensors that are allocated to those, the chain or the belt itself. If that was loose, that can cause anomalies between those two areas, and that can have a knock-on effect, if you pardon the pun, with the ignition timing. Spark plugs, we've already mentioned that, so I won't labour the point too much, but getting a spark plug with the incorrect heat rating, if the spark plug is rated as too hot, it's going to retain more heat. And when it retains too much heat, it becomes a hot spot that can ignite this air and fuel mixture inside the cylinder before the spark actually fires. Just check the plug, the numbers on the plug, and see if that corresponds with the manufacturer's recommendations. It's not unheard of for mechanics and garages to just use a generic set of plugs without doing the research, particularly if the manufacturer offers high performance models and lower performance models that essentially use the same engine but are just tuned differently. If the engine is running too lean, that would present ideal conditions for detonation or knock to happen. Now, what causes this? Well, an engine running lean is basically not enough fuel for the amount of air coming into the engine. We've either got too much air coming into the engine, or more usually, we're not getting enough fuel, or the fuel is not atomizing correctly. That's generally down to the fuel system, the injectors, the spray pattern from the injectors. We might have a leaky fuel system, so not all of the pressure is going where it should, and this will often result in hesitation, flat spots in the power band. It can also be caused by split intake hoses, vacuum leaks, split connectors in the engine bay, a faulty MAF sensor, or even a weak fuel pump. Using our diagnostic tool, we really want to check the fuel trims, just make sure that they're within the correct ratios that we would expect and we're not running towards lean most of the time. We might also check the injectors, do a fuel pressure test. We could even send the injectors off for cleaning if we suspected that they were starting to degrade. The knock sensor can also cause a detonation if that becomes faulty, but you will typically get an engine warning light or an engine management light flashing up on the dashboard, and that will show when you do a diagnostic check and you download the diagnostic trouble codes. Overheating engines can cause this problem, and it's generally down to the cooling system. The water pump may have degraded to the point it just can't flow the water around the engine sufficiently. It could just be a stuck thermostat causing the water to be locked inside the engine rather than going through the radiator as it should. But an increase in temperature provides the ideal conditions for detonation to occur. The EGR can also cause problems. If the EGR, for example, had stuck closed, that can cause a rise in cylinder temperatures and combustion temperatures, providing ideal conditions for detonation to occur. You may just have to clean the EGR shower valves, they're generally fairly easy to get to on most engines. They might require a little bit of dismantling of the intake system, but they're generally a separate module attached to the intake system, and they can be removed and just cleaned or inspected. Oxygen sensors, lambda sensors, if these are faulty, they're giving incorrect readings back to the ECU. That can cause the ECU to make incorrect calculations. It might advance the timing too much. It might cause the fuel to run lean or to run rich. And all of these can present problems elsewhere in the engine, accelerating carbon buildup, for example, or just generally increasing the combustion temperatures. Compression ratio can also cause this. If there's too much compression going on inside the engine, that can cause detonation and knock. Now, this typically only happens if we've had the engine rebuilt. Maybe we've rebored it. Maybe we've fitted a stroker kit. We've changed the compression ratio of the engine in some way. So if these things manifest themselves after we've done extensive modifications, it may just be a case that we've done our calculations incorrectly, and we need to go back to the drawing board and just reduce the compression ratio of the engine, or make mitigations so the engine can cope with this higher compression. Adding water injection, forcing a much higher octane of fuel can go some way to mitigating that problem on a highly tuned engine if we're starting to get knock or detonation. Turbocharger problems can impact detonation, particularly if it is over boosting. It's pushing too much air into the engine. That can increase the pressures as the compression takes place, and that can cause a detonation. We've just had the car mapped, or we've added a tuning device to the car that changes the timing. If we start to get knock or pinking, then something is not right in that map, in that setup, and we just need to dial it back, maybe take it back to factory conditions, see if the problem is still there, and then gradually advance things on until we start hitting the point of detonation, and then we know where the threshold is. If we're burning oil, that can cause significant detonation. Any oil going into the combustion chamber is effectively often there before the fuel gets there, on a direct injection engine particularly, and this can pre-ignite. It can cause these hot spots that ignite the fuel at the wrong time when it does arrive. Doing a compression test, a leak down test, and inspecting the PCV can go a long way to diagnosing if this is the problem or not. Mechanical hot spots, we can't ignore these little scratches, little particles of metal that are sticking out from maybe the top of the cylinder wall or on the valves themselves. These can actually cause hot spots. They're going to run a little bit hotter than the metals around them because they're sticking out. The heat doesn't transfer away from them at the same rate, and that can cause detonation or pre-ignition. And stripping the engine down or using a borescope is probably the only way we're going to diagnose that problem. And it's typically only going to happen after we've had damage to the engine, or the engine has been apart and repaired. The easy checks then: wrong fuel, that's by far and away the most common thing. We might as well want to check there's no error codes coming from the OBD2 port. Cooling system issues, and just checking the spark plug condition. If there's a lot of soot there, or we've got the incorrect grade of spark plug in terms of heat rating, that can go a long way to causing detonation. Then we've got the problems of carbon buildup, vacuum leaks, fuel pressure problems, knock sensor faults, O2 sensor fault. These can all go and cause problems with detonation. And then we've got the more advanced faults that we've covered in this video. Hopefully this will go a long way to helping you track down the problem of pinking. Don't ignore it. The engine damage is generally cumulative if we allow this to continue, and in most cases the engine is just warning us there is a problem, and it's usually one of these faults starting to manifest itself or starting to appear, giving us an opportunity to catch it early on and save ourselves a little bit of repair cost. I hope you found the video useful. Please boot the like button. I've lined up this video and this playlist that will just help you to get the best long life out of your car, to keep on top of all the maintenance. And if you're not subscribed to the channel, please do so. That would really help us to get out there, and you won't miss out on the great video content we've got planned. Thanks for watching. See you in these next videos.